Hello everyone, thanks for stopping in. Today we're going to talk about Math 120, section 5.5, and this deals with some properties we have. The first is the commutative property, which is true for both addition and multiplication. And what that says, if you take two numbers and add them together, then you can flip the order and the sum will still be the same. Think about it, what's 2 plus 5? 7. What's 5 plus 2? Also 7. Same for multiplication, right? If I do A times B, that's the same as B times A. What is 4 times 6? Well, it's the same as 6 times 4, right? So that's the commutative property. We can multiply and add in different orders. Can you subtract or divide? No. Those order matters, right? Subtraction and division, the order does matter. The associative property is also true for addition and multiplication, but not for subtraction or division. And let's take a look what that one is. If I want to add three numbers together, A plus B plus C, I can choose to add B plus C first, or A plus B first. It does not matter which one I add first. I was getting ahead of myself because multiplication, the same is true. Let's take a look here. A times B times C versus A times B times C. Which ways can I multiply? Well, I can put parentheses around the B and C or around the A and B, and it will not change the answer to my question. As long as I'm multiplying three things together, it doesn't matter if I multiply the first two or the second two first. Notice all the operations are addition or multiplication for the appropriate property, right? There's no mixing of operations here. The next property will be the first one that mixes operations, and that's the distributive property. We have A times B plus C. Well, this is the same thing as A times B plus A times C. I can pick the A up, and if I wanted to grab another marker here, I can pick the A up and distribute it through the addition. I multiply it to both. And this is what we have some examples of here. We have 3 times 4 plus 5. Well, this is the same as 3 times 4 plus 3 times 5. I can distribute the 3 to the 4 and the 3 to the 5. If you like to draw the little arrows, that's fine as well. I can distribute, right? Now, if I solve this problem, it should give me the same answer, which would be 12 plus 15, which is 27. On the homework, be careful. Sometimes it might ask you just to distribute. Other times it might ask you to simplify. Make sure you know which one it's asking. So make sure you're aware of things like that. Now, you might ask yourself, 102 times 11, how does this distributive? Well, I'm going to rewrite 11 times 102. I'm going to use the commutative property to switch the order. Now, I am going to rewrite 102 as 100 plus 2. Because when I distribute, 11 times 100 is 1,100, and 11 times 2 is 22, which tells me I get 1,122 as my answer. Now you might wonder why you would do this on pen and paper, and you mostly wouldn't. This is one of those mental math tricks, right? Sometimes people use these properties, they switch the order, they break things up. They use these properties to shortcut the mental math. If you ever see someone being really clever with mental math, they seem really sharp, they're probably using some of these properties in order to make the problem easier. This problem is much easier mentally because multiplying by 100 and multiplying by 2 is a lot easier than multiplying by just 102, right? It helps us save some mental work. Now, in our next one, we have 2 times x minus 3. Well, we can pick the 2 up and bring it into the parentheses. That'll give us 2 times whatever x is. 2 and 3 make 6. So the distributive property also works if it's subtraction, right? It doesn't change if it's subtraction. So we could have put a little minus sign here as well. We can also distribute over subtraction, right? 2 times x minus 6. Then here, in the last example, if I want to pick the 5 up and distribute it, 5 times 2 is 10, plus 5 times the square root of 3, which remember you don't need to write the multiplication if you don't want to. And we're done. We cannot go any farther. Remember, addition only plays nice with square roots if both things being added have the same square root attached to them. This 10 has no square root symbol attached to it. I cannot combine it with this 5. This is not equal to 15 square roots of 3. Very much not equal. Not the same. They are very different numbers. Do not combine them unless they have the same radical. Remember, that's why we learned that property, because they don't always combine. Addition does not always play nicely. And that was a short and sweet section. We're all done with 5.5. I will see you next time.